Okay, review packet number 24, topic 15, A and B. So we want to graph the parent function with a dotted line and then the given function with a solid line. I'm probably going to do mine in two colors. So I'm going to do my parent function in red, and I'm going to do the given function in green. So this I will do in green, parent function in red. So my parent function for this is going to be y equals the square root of x. And now when I'm doing this, if I have a reflection and a stretch like I do here, I'm actually going to graph the reflection, not just the parent function. I can graph just the parent function. The parent function would be this. Maybe I'll do three colors. All right, here's my parent function. We'll do my parent function in red. Here's x, here's y. We know it has to be positive, so let's pick some perfect squares. So 0, I've got 0. 1, I've got, or 4, I've got 2, right? The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So here's my parent one, 0, 0, 1, 1, and 4, 2. But because of the reflection, when I move things, it's actually easier to do it as y equals -2 times the square root of 2. And that probably should not be a 2 there. That should be an x. X. Okay. So let's again pick some 0, 1, and 4. But this time when I put 0 in, I still get 0. But the square root of 1 is 1 times -2 is -2. Square root of 4 is 2 times -2 is -4. So this becomes 0, 0, 1, -2, and 4, -4. So these are actually my points that I'm going to end up moving. So I am moving it up 4, which means this point here, this purple dot here, is going 1, 2, 3, 4. This one here, 1, 2, 3, 4, and 1, 2, 3, 4. And you can see why I would want to do my reflection and stretch first. Because if I started with my parent function, I just tried to move up 4 from there, I would not get even the same shape. So my parent function is this, but what I actually want to do my movement from is this piece here, -2 times the square root of x, with the reflection and the stretch. And each point moves up 2, and now this green line is my new function. So my domain, my x values start at 0, and they go on forever, all the way to infinity. My range starts at -infinity, and then it stops here at 4. Oops. There we go, so you can see that. So again, my domain, I'm starting here at 0 and going all the way to infinity this way. My range, I'm going as far as -infinity, and I stop when I get to 4. All right, let's try the next one. So again, on this next one, just graphing the parent function, it's the same thing. If I just graph the parent function, I have 0, 0, 1, 1, and 4, 2. So that's just my basic parent function. Oh, no, sorry, it's cube root. Oh, I gotta pay attention. Okay, cube root. That is not my basic. So let's do the parent function for that. And I'm gonna have to get rid of these, which makes it a little bit, gonna make it a little hard to see my x's. This is why you should always read the problem carefully, and I didn't do that. All right, there we go. Okay, so my basic parent function would be the cube root of x. So if I make a little table here, let's pick some that are perfect cubes. So for example, -1, 0, and 1. The cube root of -1 is -1, the cube root of 0 is 0, and the cube root of 1 is 1. So I've got -1, -1, 0, 0, and 1, 1. And you have this sort of point of inflection right there. It goes like this, and then kind of changes concavity and goes that way. So that's my basic parent function. But again, we want to kind of do it with the stretch in there. So let's do y equals 2 times the cube root of x. So I've got, again, I want to use ones that make perfect cubes. So negative 1, 0, and 1. The cube root of negative 1 times 2 is negative 2. The cube root of 0 times 2 is 0. The cube root of 1 times 2 is 2. So I've got negative 1, negative 2, 0, 0, and 1, positive 2. So I'm going like this, and then changing and going like that. And now I need to move it, so I'm going to do it in green again. I need to move it. So this negative 1 right there means that I am moving to the right 1, and this negative 5 right there means I'm going down 5. So each point that I just plotted, so this point right here, I'm going to move right 1 and 1, 2, 3, 4, I'm off the graph 5. And then this point here to the right 1, 1, 2, 3, 4, 5. And then this last point here, I'm moving to the right 1, 1, 2, 3, 4, 5. So my function actually looks like this. And then my domain, well, it keeps going as far left as negative infinity, as far right as positive infinity, and my range is the same thing. It goes down forever, and it goes up forever.